In this video, we'll see a few more examples about the reflection or the flip of one figure over the reflection line and how it looks like if I have the reflection line going through the figure. So one of the problems that can happen is the reflection line actually goes through the figure. So the pre-image and the image have to be moving every vertex the same distance from the reflection line and away. So to the reflection line and from it, to the reflection line and from it. So these two vertices will be on this side, and these two vertices will have to move over to that side. So if I keep that image and have another to compare with, just so I can see how the trapezoid before will flip over to see how the image and pre-image would look like. So thinking about what is going to happen to the vertices of the shape if the reflection line goes through it. Let's see a few examples of line outside and line going through the shape. So in the first example I have, or example number 3 because we continue, reflect over the reflection line x equals 2. X equals 2 is a line going through x2. So we have to draw the reflection line first and then transfer the trapezoid over the reflection line. So let's say I label A, B, C, D trapezoid, and you can start with any point. So let's say I transfer point B first, and it is 1, 2, 3, 4. So full squares, 1, 2, 3, 4. 1, 2, 3, 4 should be B prime because they have to be the same distance away. A has 1, 2, 3, 4, 5, 6 units. 1, 2, 3, 4, 5, 6, 7, 8. So to the reflection line, 1, 2, 3, 4, 5, 6, 7, 8 away, and that would be 8 units, same distance to the reflection line and away. Point C, to the reflection line, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 units away, C prime. Point D, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 away, D prime. So if I connect my vertices now, the image is showing the flip over the line with the equation x equals 2. That is the line that crosses point 2 on the x-axis. Okay. ABCD is a quadrilateral and we reflect it over y equals -1. So the reflection line y equals -1 is a line that goes through -1 on the y-axis. So here's my reflection line, y equals -1. Now, the quadrilateral has to be transferred over, flip over. So let's say point D has to be 2 units away, D prime, same number of units. Point A needs to be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 units away, A prime. Point C, 2 units, C prime. And point B, 1, 2, 3, 4. 1, 2, 3, 4, B prime. When you connect, make sure you connect all the vertices. And the image shows now the reflection over the line with the equation y equals -1, where all the vertices of the original figure, which is the pre-image, are the same distance away from pre-image. So from the reflection line, same number of units away. Now, in the next example, I'm going to have to reflect over x equals 3. X equals 3 is a vertical line going through, oops, sorry about that. X equals 3 is a vertical line going through x-axis. That's the equation of my reflection line. And this is when I have to twist my parallelogram around this reflection line. So if I was to use a parallelogram, let's say something similar, I have a parallelogram and then I put my reflection line through, then what's on the right will twist to the left. Okay, what's on the left will twist to the right. And when the reflection happens, then the pre-image and image on the paper overlap. So we have here, let's say A, B, C, D. Point A is on the reflection line, so it overlaps with A prime. Point B is 3 units away, so that would be B prime right here. Point D was on the left, so it's going to transfer over to the right 1 unit away, D prime. And point C is on the right, so it's going to transfer to the left 2 units away. So now when you connect your vertices A with B, here is your A prime, B prime, B with C prime, C with D prime, so C prime with D prime, and then A prime with D prime. Here is the twist, which overlaps with the pre-image because we spun it around the reflection line. So thinking about this parallelogram spun around, okay, or flipped over. Reflection over y equals -6. So first we draw the line of reflection. 1, 2, 3, 4, 5, 6. Negative. Before I use my highlighter, I want to make sure that I count again. 1, 2, 3, 4, 5, 6. Okay. That is my reflection line, y equals -6. Now the triangle is going to be flipped over that line of symmetry. So let's say if I use a triangle, what happens in the reflection? So here's an example of a triangle. So I have 1 vertex and then 2 on the bottom. So in the reflection, what's going to happen is this 2 from the bottom goes to the top, and this one comes on the other side. So flip over the horizontal line. That's your flip right there. So thinking about what happens to the vertices, they move the same distance to the reflection line and away. So point A goes down 2 points. That will be your vertex A prime. Point C goes across up 2 points, 2 units, C prime. And point B goes across up 2 units, B prime. Now we have to find those new vertices carefully. So A prime with B prime, connect. And B prime with C prime, connect. And then C prime with A prime, make sure they're all labeled so we can make the proper connections. And then when you look at the pre-imaging image, see how the flip happened. Okay. The vertex A turned over to the bottom, the vertices B and C twisted over to the top. In the next example, we have to look at 3 triangles and describe what happened. So the figures to the right are congruent. Figure 1 and 2 and 3 are congruent. Identify a transformation that maps figure 1 to figure 2. In other words, what happened from figure 1 to figure 2? So you're interested only looking at this 2. 1 and 2 are mirror images of each other. So what you can say is that figure 2 is a reflection over the y-axis. So this is a reflection over the y-axis. So to describe this, to identify the transformation, you say that figure 2 is a reflection of figure 1 over, and you have to make sure that you specify what transformation, reflection, and over what? Over the y-axis. So to identify the transformation, that's a reflection. In the reflection, we always have to say over what was reflected. So every time we reflect something, we have to reflect it over something. So the figure 2 is a reflection of figure 1 over the y-axis. Then identify the transformation that maps figure 2 to figure 3. So that means what happened to figure 2 to get figure 3. So this is another flip, but this time is over the x-axis. So when I look at this figure number 3, figure number 3 is a reflection of figure 2 over the x-axis. So to describe that, we need to say that figure 3 is a flip, a reflection of figure 2. And then if you have a reflection, we always say over what? Over what is the line of symmetry? Over x-axis. So figure 3 is the reflection of figure 2 over the x-axis.